Hi, this is a first video for assignment 44 notes, and assignment 44 is more or less a review assignment of the previous couple assignments. But it's good to see some of the material again. We're going to be first looking at graphing logarithms and maybe giving you a little bit of a shortcut for graphing logarithms. So if we want to graph the function f of x is equal to log base b of x, we're going to go ahead and look at the table for the inverse, which is usually a little bit easier to generate. So the inverse function would be the exponential of the same base, base b. And we used a 3-point method for graphing it. And those would be, the 3 points would be -1, 0, and 1 for the x values. B to the -1 is 1 over the base. B to the 0 is 1. And b to the first power is b. The horizontal asymptote in stock form is y equals 0. And here's roughly what the graph would look like. So -1 and 1 over b, 0, 1, and then 1 comma b. Horizontal asymptote y equals 0. And I have graphed exponential growth. It could certainly be exponential decay as well. All right, and there's your b to the x. Let's go ahead and also mention the domain and the range. The domain of the exponential is all real numbers, and the range is all positives. Now, to graph the inverse, all you got to do is switch your x and your y. So we're going to switch x and y in our tables, x and log base b of x. So we're going to have 1 over the base and -1, 1 and 0, base and 1. Instead of having a horizontal asymptote of y equals 0, we now have a vertical asymptote of x is equal to 0. The domain and the range will be switched. So the domain will be all positives, and the range will be all real numbers. We'll go ahead and try to plot those points. So we have 1 over b and -1. And then we have 1 and 0. And then we have b and 1. And so there's the graph of our logarithmic function. I think in assignment 43, when you looked through those notes, you were given more than 3 points to graph, and you can certainly graph it that way. Here I'm just giving you a little bit more minimalistic approach with only 3 points in the asymptote. So we're going to look at graphing some transformations in this section here also. And so what we want to do is, like any time when we do transformations, we want to graph the parent function. So here we're going to look at log base 1/3 of x plus 4. I believe I have a little, yeah, there we go. X plus 4 and then -3. So we're going to identify the base, which is 1/3, and we're going to look at the exponential of 1/3 to the x power. Be evaluated at -1, 1/3 to the -1. You're just going to take the reciprocal of that, so 3 over 1 is 3. 1/3 to the 0 is just 1, and then 1/3 to the first power is just 1/3. Horizontal asymptote is going to be y equals 0. Now we're going to switch x and y to come up with the logarithm of base 1/3. And that's the inverse of the exponential of base 1/3. So just switch your ordered pairs. So 3, -1, 1, 0, 1/3, and 1. We'll go ahead and plot those points. So 3 and -1, 1 and 0, and then we'll do our best to try to guesstimate 1/3 and 1. And then instead of having a horizontal asymptote of y equals 0, because you switch x and y, it becomes x equals 0, and that's a vertical asymptote. And so this is how we graph transformations. First we graph the parent function, and then we use what we know about transformations to graph the transformations. Okay, now you got the x plus 4. If it's inside with the x, that's going to control left or right, and it's going to do the opposite of what you expect. So the plus 4 is actually going to cause us to go left 4. Now if you have any sort of shift left or right, that's going to affect your vertical asymptote. And so your vertical asymptote, instead of x is equal to 0, is now switched to x is equal to -4. Okay. All right. So we'll put that in. And then we're also going to slide it down 3 units, which will not affect the vertical asymptote. Okay, so then we're going to take our 3 points and we're going to move them to the left 4. 1, 2, 3, 4, and then down 3. 1, 2, 3. Okay, and then the next point. 1, 2, 3, 4. 1, 2, 3. And then the last point. 1, 2, 3, 4. 1, 2, 3. Okay, and then we'll connect, and it's going to have the same shape as the original, the parent function. Then we'll go ahead and label that. Okay, and that is it for this one. We're going to look at 2 more graphs of logs, so let's go ahead and do another one. So we're going to graph f of x is equal to negative log base 4 of x minus 1 plus 2. Okay, now the base of the logarithm is 4, so we're going to look at the exponential of 4 to the x. And we do this so we can generate the logarithm of base 4. So our ordered pair is negative 1 and 1/4, 0, 1, 1 and 4, horizontal asymptote, y equals 0. Now we're not going to actually graph this, but we are going to switch our x and y to get the log of the same base. So we have 1/4 and negative 1, 1 and 0, 4 and 1. The vertical asymptote of x is equal to 0. Okay, so we're going to plot the point 4 and 1, 1 and 0, and then we'll do our best to try to graph the 1/4 and minus 1. We'll put in our vertical asymptote and then sketch our logarithmic graph, and we'll go ahead and label it as well. Okay, so now we're going to graph the transformation. So we're going to work inwards, outwards, so we have x minus 1 inside. That's going to control the left or right, so that's going to go right 1. And so that's a horizontal shift, so that's going to shift our vertical asymptote to x equals 1. So we have a new vertical asymptote of x is equal to 1. Okay, then we got the negative on the front of the function there, and that's going to cause a reflection over the x-axis. And then finally, the plus 2 is going to cause us to go up 2 units. So, with our points, let's go ahead and do those transformations. Okay. All right. So we went right 1, and then reflect. This point here is on the x-axis, so it doesn't move anywhere. And then up 2. Oops, too far. And then this point here, go right 1. Reflect, and then up 2, and then the last point, go right 1, reflect, and then up 2. Okay. And there we have it. And we'll go ahead and label our graph. And we're going to look at one more graphing logarithm. So this time we're going to graph f of x is equal to log base 4 of negative x plus 2. Again, this has the base of 4, so we're going to generate the table for 4 to the x. And so why we do this is we don't have to memorize a whole bunch of tables, we just have to remember how to generate the table for the exponential, which allows you to obviously graph exponentials, and then to do the log, all you got to do is switch your x and y. So it's less things for us to remember. Okay, horizontal asymptote, y equals 0. Okay, so we'll switch our x and y. So we already did this on the previous slide. So we'll speed it up a little bit and plot those points. And so we already graphed log base 4 of x on the previous slide there. So let's go ahead and label it. Alright, so now we're ready to graph log base 4 of negative x plus 2. And I got the negative inside the function there, and that's going to cause a reflection over the y-axis. And then we have the plus 2 on the outside, which is going to go up 2. So what's going to happen is we're going to reflect over the y-axis and go up 2. That's not going to affect our vertical asymptote here. So let's start at this point here, reflect, reflect and then up 2. And then the next point we would reflect all the way to -4 and then up 2, so I think we're going to be around there. Okay, and then finally the last point here, reflect and then up 2. Alrighty. And then we'll go ahead and sketch our logarithmic function and label it here. And then just as a refresher, if you have the negative on the outside of the function, so negative f of x, like in the previous example, that's going to cause a reflection over the x-axis. And then if you have a negative inside with the x, so f of minus x, that's going to cause a reflection over the y-axis. Okay? We're going to look at one other thing real quick here in this video. We're going to look at finding the domain in the range. Okay. So if f of x is equal to log base b of x, the domain is all positives and the range is all real numbers. So let's say we wanted to find the domain of log base, well, what base is that? There's no base. It's base 10, remember. And if there's no base there, it's either base 10 or base e. So if it's log, L-O-G, that's going to be base 10. So log of 5 minus x. We want the argument to be positive, so 5 minus x must be greater than 0, plus x to both sides, so 5 is greater than x. So our domain is going to be from minus infinity to 5. Now we can do a very rough sketch of this, okay? So what makes the argument 0? So 5 minus x is equal to 0. That's when x is equal to 5. That's where our vertical asymptote is going to be. And we know that the domain is negative infinity to 5, so that means we can't have anything over here. And so there is our logarithmic function, just a real rough sketch. And from there we can see that our range is all real numbers. And we also have up here that our range of a log is all real numbers. All right, let's do one more. F of x is equal to ln, or natural log, of 17 minus 3x. And what was the base of natural log? Remember it was e? Okay, it had its own special notation. And actually we wouldn't put the e there, we would say log base e of 17 minus 3x would be what that is. Okay. And logarithm is a happy creature. It does not like being fed anything negative, so we're going to go ahead and who cares about the plus 2 there? That doesn't affect anything at all for the domain. The domain only worries about what's inside the logarithm. Okay, so 17 minus 3x is greater than 0, so add 3x to both sides, divide by 3. So 17 thirds is greater than x. So your domain is going to be negative infinity to 17 thirds. Okay, now if we wanted to do a sketch, well, what makes the argument 0, the 17 minus 3x is equal to 0, is 17 over 3. So that's going to be somewhere about there. There's your vertical asymptote. And it can't be over here because the domain is less than 17 over 3, or x has to be less than 17 over 3. And so we have a similar graph to the previous one. Again, we know that the range of a logarithm is going to be all real numbers. Okay. Alrighty, well, I think we have 2 more videos, so this is a little bit longer since we're kind of doing a little bit of a review of stuff that we've talked about this week. So I see you on the next one.